So for VLSM, variable length subnetting, basically this method is used to cut down on the number of wastages. So you see here, for example, I only need what we call 5 subnets and 20 hosts, but I created 8 subnets with 30 hosts. I don't really want to waste any more subnet, provided right now I have another scenario. In this particular scenario, okay, I may want to create perhaps an individual subnets, okay, another subnets, okay, subnets, or maybe sometimes there may be what we need to create from here, 2 links, and then each link from the interface here, okay, we'll need to have IP addresses that connect to another router, okay, and then another router here, okay. So I need to create another 2 IP addresses, but I have to use another subnets to create these 2 IP addresses, okay, because all the subnet 5, 1, 2, 3, 4, 5, all I've already allocated to HR, engineering, sales, marketing, or whatever, okay, or procurement. Now I want to take out another 2 more. I need to create another 2 more subnets, okay, so that I can create a serial link to another 2 router, okay. So they have to be in another subnets, all right, cannot be here. So how am I going to do it? That is the question. So this is where VLSM comes in very handily, okay, because we can create subnet from another subnet, all right, and we don't have to waste any more bits by creating 6 subnets, or of course I can use the remaining 3 but assume I have 8 departments and all use finish, assume that okay. I have 8 subnets all use finish, then I don't want to break out anymore, okay. In this case, I will break out from here. Okay, this is called VLSM subnetting. Okay, so in this, our requirements will be, we need to create, okay, another 4 subnets maybe for small department. Okay, for small departments. Okay, and this department basically will only have 4 hosts. Okay, 4 hosts, 4 IP addresses. 4 hosts, 4 computer only. Well, it seems to be a very small department. Maybe it's some audit, no need that many kind of number of people inside there. So in this case, how am I going to do, since I have fully utilized the 8 subnets already? Okay, so I will borrow from here .1.1.1.96. Okay, so the same thing. What I'm going to do is that I'm going to borrow bits. Okay, going to borrow bits. So with that, this particular subnet mask, okay, we have the here 0, 0, we have 1, 1, 1, which is being borrowed already, okay. Then the rest are 0, then 1, 2, 3, 4. Okay, I have this. Okay, these 3 are already borrowed, so I will highlight them in red so that to show you. Okay. Okay, I highlight them in red. Okay, so now from these 3 already used already, I left this thing. Okay, the 5 host bit. Okay, I want to do VLSM. I need to create 4 more subnets, and each subnets okay, 4 hosts will it be enough or not? Okay, so if I borrow 1 bit, 2 to the power of 1, okay, I will get 2 subnet. Okay, yeah, one bit will give me 2 subnet. If I borrow 2 bits, okay, 2 to the power of 2, okay, I will be having 4 subnets. So I need to borrow 2 bits. Okay, borrow 2 bits. So I need to borrow 2 bits from the host portion here. So let me put it in, this time I put it in green. Okay, in green. I need to borrow another 2 bits so I can create 4 more subnets. Okay, 2 to the power of 2 equals 4 subnets. Okay, then how many host bits I left? I left 3 host bits. Okay, so these 3 host bits inside here, 2 to the power of 3. Okay, I have 8. 2 to the power of 3, I have 8 IP minus 2. That will give me 6 usable IP addresses. All right. So I have determined how many bits I need I need to borrow, okay, and then the new subnet mask will also form. Okay, so over here now I have this thing. Okay, the next thing I need to do is I can create the what we call the network address, the 4 network address here. So I can put the first, second, third. Okay, this one will be created from 1 dot, okay, 1.96, because if I put a dot 1 here, it will change to decimal point. Okay, it will change to something else. Okay, from here I will do the VLSM. I'll create a further subnet from this subnet. Okay, so over here I will borrow 2 bits, and based on what we understand here, okay, this magic number is a way in helping us. Okay, magic number. So what will be the magic number? So over here, my magic number will be the last bit here. Okay, will be the last bit here. So I highlight that in orange. Okay, so basically this one is, if I change this to power of 1, okay, okay, now I have all these as the net mask 11111 0 0 0. Okay, the last bit here will be my magic number. This magic number, okay, which is the orange color one, okay, is now changed to 1. Okay, the magic number that is representing here, the power 2 to the power of 0, 2 to the power of 1, 2 to the power of 3, 2 to the power of 2, 2 to the power of 3. So this one is turned on at 2 to the power of 3. So the magic number is equals to 8. Magic number is equals to 8. Okay. If you want to do manually without the magic number, also can, okay, but let me just show you how the same repeat of the earlier, how do I do the magic number. So I have a magic number of 8. Okay, so in this case the first subnet I will having is 192.168.1.96, which is I borrow from here. Okay, then the second subnet 192.168.1.96 plus 8. 104. Okay, with 104, the third subnet created will be 192.168.1 plus 8, 112. Okay, and the fourth subnet that I create from here, 192.168 plus 8120. This will be the 4 subnets I created. All right. So basically it's the same thing. If you do some bits manipulation, okay, a very manual way of doing it, okay, will be the 4 subnets you create from here, 1 1 1, sorry, original 196 96. So is this IP address 96 IP address as well. Let me just check it out. 6. Okay, 01100000. This is a very manual way of doing it. 01100000. Okay, so over here this is 96. Okay, then after that 0110. Remember, these are the 2 bits that I borrowed. Okay, so what kind of transition I can have? I can have 00. I don't think you guys will be doing this way, very manual one. 0 0 0 1 1 0 1 1. This will be the 4 pattern. Okay, so over here I will have okay 0 1 1 0 1 0 0 0 0 1 1 1 0 0 0 0 0 1 1 1 1 0 0 0. So this will be the 4 subnets that we have. So what I'm showing you right here is actually the manual way of getting the IP addresses for the network. Okay, but we use the magic number, so it's a bit easier. So I show you two-way. The magic number is taught by the Cisco NetAttack. Okay, they don't use this very primitive way. This is where we learned last time, in our old poly ways, on how to do it. Okay, so will be this IP addresses. All right, so this will be the 4 IP addresses. So over here at the same place, first IP, last IP, and broadcast. Okay, so first IP, last IP. So this will be 103, 103. Okay, this will be 102. This will be 97. Okay, and this will be 105. This will be 110. Because this is the last one, will be 111. Okay, and then over here we have 113, we have 119, 118. Okay, and here we have 121. Okay, then so on and so forth. Okay, so basically you can add it on yourself. 3 plus 5 is 18. 121 plus 5 is 126, then 127 over here. Okay, so this will be the 4 subnets I created, and each of the subnets, I have 6 usable IP addresses. And what will be the new subnet mask, ladies and gentlemen? Okay, since I have borrowed another 2 bits from this /27, okay, so this will be what? /29. First time I'm teaching using Excel. Okay, will be /29. So what will the subnet mask be? 255.255.255. Okay, so 29, that means I have left with only how many bits? Last 3 bits, 30, 31, 32. So here, if I sum it up, will be 1111, then 11000. So 0, 0, let's check. 129 bits. Okay, last 2 bits, last 3 bits are not used. Okay, so I got this, and what will the decimal equivalent be? Decimal equivalent will be equals to 11110000248. So will be 255 dot 248. Okay. So if I have any packets coming in for this IP addresses range, our router will need to do a logical AND. Okay, let's assume that basically some packet comes in and one packet comes in into this direction, okay, into the router, and then our router, this packet is carrying carrying 192.168.1 168.1 dot maybe 108. Okay, so I will do a logical AND with my subnet mask. Okay, 255 248. So that will give me 192.168.1. Okay, 108 AND with 248. Okay, so let's see which subnet will we go to. Oh, it should not go to here. Go to here, something big problem already. Oh, so which the router will try to find out this particular packet. Okay, incoming packet. Okay, which subnet, which interface it should route to. Okay, so in this case, I take Okay, I take 108. Okay, you can do manually. 1 and 1 is, you can put it in binary and do manually. It's up to you. Okay, and 248. Okay, it belongs to subnet 104. Is it correct? Yes, it's correct. So we have successfully applied VLSM. So over here, the router will find that it belongs to this subnet .1.104. So you go back and look at the router table .1.104. It actually go to serial 0/0/0, then it will send out to this particular interface. So this is using VLSM.